Hi, and welcome to Organic Video Tutorials. Today what we're going to be talking about is condensation reactions. And yes, condensation reactions are a type of organic chemical reactions. Before we get into the details of condensation reactions, I want to outline the objectives that you should be able to accomplish by the end of this video. The first of these objectives is that you should be able to simply define what a condensation reaction is. You should also be able to describe what the general products are as a result of condensation reactions. And that final objective that you should be able to accomplish is you should be able to determine the general mechanism that occurs in the production of aspirin. So without further ado, let's get underway. So condensation reactions are simply an organic chemical reaction that involves two smaller organic reactants that are used to produce a larger, more complicated organic product. And you may be wondering, well, what is the importance of condensation reactants? Well, condensation reactions play an impact on our everyday life. Examples include the production of aspirin and also the production of artificial flavoring, such as this artificial banana flavoring. So when exactly do condensation reactions occur? And condensation reactions occur when we have two smaller organic molecules combine to produce a larger, more complicated organic molecule. What is also produced as a result of a condensation reaction is a smaller molecule. Typically, this molecule is going to be water. So simply put, a condensation reaction is just an elimination reaction that allows a larger organic molecule to be produced. So as an example of a condensation reaction, we have one listed at the bottom here. And so this condensation reaction has a specific name, and this condensation reaction is known as an aldol condensation. So with an aldol condensation, we have two ketones as our reactants. Now, just a reminder of what a ketone is. We have a carbonyl group. Remember, the carbon attached to the oxygen, the carbonyl group. And attached on each side of this carbonyl group are additional carbon chains. These R's in both of the reactant just represent that additional carbons can be attached in the place of that R. So what happens for this aldol condensation is this. This first ketone has these two hydrogen atoms eliminated from this particular reactant. The second ketone has this oxygen eliminated from this organic reactant. Now, these two hydrogens and the oxygen that are eliminated from each of the reactants combine together to produce H2O, or water. What this elimination also allows us to do is it allows us to make more room to have or to produce that larger organic molecule. So the remaining portion, after we've eliminated this oxygen, the remaining portion of this ketone is now able to attach to the portion of this first reactant. And so they combine together to produce this larger organic molecule, and this organic molecule here is larger than any of these two reactants. So let's get a little bit more in detail of what condensation reactions are. So with condensation reactions, to help us understand what is occurring during a condensation reaction, we have a few mechanisms of what is happening during this reaction. So for our first example, we have ethanoic acid and 3-methylbutanol combined together in our organic reaction. Now, what happens here is the hydroxyl group, the OH of the ethanoic acid, is eliminated off of that reactant. With the 3-methylbutanol, it has a hydrogen atom eliminated. Now the OH from the ethanoic acid and the H from the 3-methylbutanol combine to form H2O, or water. What this elimination also allows us to do is to combine these two organic molecules to form that larger organic molecule. So what happens here as a result of this elimination of these two atoms from the reactants, it allows us to produce 3-methylbutyl ethanate, which is that larger organic molecule. So to illustrate what is happening here, I'm going to outline what happens or what occurs during the synthesis of an ester. So with an ester, what we start out with is a carboxylic acid and an alcohol. So for this condensation, what I'm going to identify first is what is eliminated off of each reactant. So off of the carboxylic acid, the H is eliminated from that reactant. And off of our alcohol, the hydroxyl group, or the OH, is eliminated from that alcohol. Now, the H and the OH combine to produce water, or H2O. What the elimination of the H and the OH of our reactants allow us to do is it allows us to create, or allows us to produce, that larger organic molecule. So as a result, the following larger organic molecule is produced. Again, the product that is produced is larger than any of these two reactants. This is important. This basis of the synthesis of an ester, or this type of condensation reaction, is important as we look into the production of aspirin. So let's go ahead and let's look in depth and in detail about what happens during the production of aspirin. So let's go ahead and let's start out with the two reactants that are involved in the production of aspirin. So the two reactants that are involved in the production of aspirin are salicylic acid and acetic acid. And before we move on, I want to have some pause and predict questions of these two reactants that are involved in the production of aspirin. So what I want you to do is I want you to classify alcohol or acetic acid as a primary, secondary, or tertiary alcohol. I also want you to identify the orientation of this attached hydroxyl group in salicylic acid. Remember, the orientation is ortho, meta, para. What is that for that attached hydroxyl group? And then the last two things here is I want you to give the IUPAC name of both salicylic acid and acetic acid. So go ahead and take about 60 seconds to answer these questions. All right, I hope you got those answers to those questions. They will be shared later on. All right, so let's get down to business about what is the mechanism or what occurs in the production of aspirin. So the first thing that I'm going to identify in this condensation reaction is what gets eliminated from each reactant. So all I'm going to do is identify what is eliminated from each reactant. So from the salicylic acid, this hydrogen is eliminated from this particular reactant. From the acetic acid, the hydroxyl group, or the OH, is eliminated. Now, the H and the OH that are eliminated in acetic acid combine to form H2O, or water. Now, what that allows us to do is it allows us a spot to be able to create or produce that larger organic product. So what I'm going to do is I'm going to draw the salicylic acid that no longer has this H, and then that second step is I'm going to attach that acetic acid without the hydroxyl group. So this first step here, all I did was draw this salicylic acid without that hydrogen group, or without that hydrogen atom. What I'm going to do now is attach that remaining portion of acetic acid without the hydroxyl group. So I am going to attach the carbon gets attached directly to that oxygen, and as a result, what is produced is this aspirin. So this is the production of aspirin. Hope you've enjoyed this video. Thank you for watching.